150,000 men stepped onto occupied European soil on June 6, 1944, carried there by a boat that naval engineers had sworn would never work. The vessel that made the largest amphibious invasion in human history possible violated every principle of sound naval architecture. Its designer had never built a military craft in his life, and without it, the entire Allied strategy for defeating Nazi Germany would have collapsed into the surf. The morning of D-Day began with 1,500 landing craft racing toward the beaches of Normandy, each one carrying 36 soldiers toward machine gun fire, artillery shells, and obstacles designed specifically to rip apart anything that approached the shore. These boats had a single feature that separated them from every naval vessel that had come before: a front ramp that dropped down to allow troops to charge directly onto the beach. That ramp, that simple hinged metal plate at the bow, represented something the United States Navy had officially declared fundamentally unsound. It violated the basic mathematics of hull design. It compromised structural integrity. It defied centuries of maritime engineering wisdom, and it was about to determine whether the war in Europe could be won. The problem of how to land soldiers onto a defended beach had haunted military planners for decades. Traditional ships could not simply drive up onto sand and unload men under fire. Troops had to climb over the sides of boats while still in deep water, dropping into the surf with full equipment, exposed and vulnerable as they struggled toward shore. The disaster at Gallipoli in 1915 had proven this with horrifying clarity. British and Anzac forces attempting to land on Turkish beaches had been slaughtered in the water, cut down by enemy fire before they could even reach dry ground. Men drowned under the weight of their own packs. Bodies piled up in the shallows. The surf ran red. Gallipoli had demonstrated that without a practical method to deliver troops directly onto a hostile shore, amphibious assault was simply mass suicide by another name. For nearly 3 decades after Gallipoli, that problem remained unsolved. Naval architects understood the theoretical requirements: a shallow draft vessel that could approach a beach at high speed, discharge its cargo in seconds, and retreat before becoming a stationary target. But the engineering challenges seemed insurmountable. Any boat shallow enough to reach the shore would be too fragile for open water. Any vessel stable enough for ocean transport would draw too much water to approach a beach. And the idea of putting a hinged ramp at the front of a boat, cutting a massive opening into the bow where water pressure and wave impact were most severe, struck trained engineers as borderline insane. The bow of a vessel was its primary structural element, the cutting edge that allowed a boat to move forward through resistance. Weakening it with a ramp would compromise everything. This was the conventional wisdom. This was what the experts knew to be true. And this was exactly the kind of thinking that Andrew Higgins had spent his entire career ignoring. Higgins was a boat builder from Louisiana, a businessman who had made his living designing shallow draft vessels for oil exploration and logging operations in the swamps and bayous around New Orleans. He understood boats that had to navigate unpredictable terrain, that needed to push through shallow water thick with vegetation, that had to be tough enough for commercial use but simple enough for rapid production. He had no formal training in naval architecture. He had never designed a military vessel. He had never worked for the government. He built boats that worked, boats that solved practical problems for people who needed to move cargo through difficult environments. And when someone suggested that the military needed a boat capable of running directly onto a beach and unloading soldiers through the front, Higgins did not consult engineering manuals or stress test calculations. He simply built one. The first prototype was crude, almost comically unsophisticated by naval standards. It had a flat bottom for shallow draft, a simple rectangular hull, and a hinged metal ramp at the bow held in place by a basic cable system. There was nothing elegant about it. Naval engineers who saw early versions dismissed the design almost immediately. The ramp created a structural weakness that would allow the boat to flex and bend in rough water. The flat bottom would make the vessel unstable in ocean swells. The lack of a proper keel meant the boat would be nearly impossible to steer with precision. Every aspect of the design violated some principle of proper maritime construction. It looked like something a backwoods mechanic had hammered together in a shed, not like a vessel that could be trusted with the lives of American soldiers. But Higgins had not designed the boat to impress engineers. He had designed it to work. The United States Marine Corps, desperate for a solution to the amphibious assault problem, agreed to test the landing craft, vehicle, personnel in a series of trials that would determine whether the concept had any merit at all. The tests were straightforward. Drive the boat onto a beach, drop the ramp, unload a full complement of troops, and back out into the water. Do it quickly. Do it repeatedly. Do it under conditions that simulated the chaos of combat. If the boat could perform these tasks reliably, then perhaps the design had potential despite its theoretical flaws. If it failed, the entire concept would be abandoned, and the search for alternatives would continue. The LCVP performed flawlessly. It drove directly onto the shore with enough momentum to beach itself firmly on the sand. The ramp dropped in seconds. Troops poured out onto dry land in approximately 18 seconds, a speed that seemed almost impossible compared to traditional side-loading methods. The boat backed off the beach without difficulty, turned, and was ready for another run almost immediately. The Marines conducting the test watched in something close to disbelief. The boat that should not work, the boat that violated basic engineering principles, the boat that looked like it had been designed by someone who had never read a naval architecture textbook, was actually superior to every alternative that had been proposed. Naval architects continued to object. They produced calculations demonstrating the structural weaknesses of the design. They warned that the boats would break apart in rough seas. They insisted that the ramp mechanism would fail under combat conditions, that salt water would corrode the cables, that the flat bottom would make the vessels uncontrollable in crosswinds. They were not being obstinate or foolish. They were applying rigorous engineering principles to a design that genuinely did violate established standards. Everything they said was technically correct. The LCVP was not a well-engineered boat by traditional measures. It was something else entirely, a functional solution to an impossible problem. Then Pearl Harbor burned. December 7, 1941, transformed every calculation. The United States was at war across two oceans simultaneously, facing enemies entrenched on islands and coastlines that could only be reached by amphibious assault. There was no more time for theoretical debates about hull design. There was no room for hesitation about whether the LCVP was elegant enough or whether it satisfied the aesthetic preferences of naval engineers. The military needed thousands of landing craft immediately, and the only design that had actually proven it could land troops on a hostile beach was sitting in Andrew Higgins's blueprints. The order came through: build them. Build as many as possible, as fast as possible. Turn the experimental prototype into a mass-produced weapon of war. Higgins Industries in New Orleans became a massive production facility almost overnight, transforming from a small boat-building operation into one of the most critical manufacturing centers of the entire war effort. Higgins implemented Ford-style assembly line methods, breaking the construction process down into modular components that could be fabricated separately and assembled rapidly. Workers who had never built boats before were trained in specific tasks, each person becoming expert in one element of the construction sequence. The LCVP was designed to be simple enough that it could be built by semi-skilled labor working at incredible speed. In approximately 2 years, Higgins Industries produced over 20,000 LCVPs, 20,000 boats, each one capable of carrying 36 soldiers from ship to shore. The scale of production was staggering, a logistical achievement that rivaled any other manufacturing effort of the war. And every single one of those boats retained the feature that naval engineers had declared fundamentally unsound: the front ramp. Those boats went everywhere the Allies needed to land. They hit the beaches in North Africa. They carried Marines onto Pacific islands where Japanese defenders waited in fortified positions. They landed troops in Sicily and Italy, each invasion refining the tactics and procedures that would eventually be needed for the largest amphibious operation ever conceived. And on the morning of June 6, 1944, 1,500 of them raced toward the coast of Normandy, carrying the first wave of soldiers who would begin the liberation of occupied Europe. Omaha Beach was hell on earth. The intelligence had been wrong. The bombing had missed. The German defenses were intact and fully manned. Artillery fire began falling among the landing craft while they were still hundreds of meters from shore. Machine guns opened up as soon as the boats came within range. Shells exploded in the water, sending up geysers of spray and shrapnel. Boats took direct hits and disintegrated, men and equipment thrown into the sea. Obstacles hidden beneath the surface ripped open hulls. Some ramps dropped to reveal nothing but a wall of machine gun fire that cut down the first soldiers before they could take a single step. The beach became a killing ground where men crawled over the bodies of their friends, where wounded soldiers drowned in the rising tide, where the surf turned red with blood. But the LCVPs kept coming. Ramp after ramp dropped onto French sand. Troops poured out into the most intense fire any of them would ever experience, but they poured out fast. 18 seconds from ramp down to full disembarkation. 18 seconds of maximum vulnerability instead of the minutes it would have taken to climb over the sides of a conventional boat while chest deep in water. The difference was measured in lives. Men still died, thousands of them, but the speed of the LCVP landing process meant that survival was at least possible. Soldiers could hit the beach running instead of struggling through the surf already exhausted. They could reach cover before the enemy gunners adjusted their aim. They could move. By the end of that longest day, 150,000 Allied troops had landed on the beaches of Normandy. They had established beachheads. They had pushed inland. The invasion that would ultimately lead to the fall of Berlin had succeeded, purchased with tremendous cost but achieved nonetheless. And every single one of those soldiers had reached shore aboard a boat that expert engineers had insisted would never work. After the war ended, after the victory parades and the commemorations and the beginning of the long process of counting the cost, General Dwight D. Eisenhower made a statement that would follow Andrew Higgins for the rest of his life. Eisenhower, the supreme commander of Allied forces in Europe, the man who had orchestrated the entire Normandy invasion, who had coordinated the efforts of millions of soldiers and thousands of vessels and countless tons of equipment, called Higgins the man who won the war for us. Not a general, not a scientist, not a brilliant strategist or a decorated hero, a boat builder from Louisiana who had never attended a military academy, who had no formal engineering credentials, who had designed a vessel that violated every principle of proper naval architecture. Eisenhower credited that man and that boat with making Allied victory possible. The statement was not hyperbole. Without a practical method for amphibious assault, the entire Allied strategy would have been impossible. There would have been no North Africa landings, no Sicily, no Italy, no D-Day. The Pacific island hopping campaign that gradually closed in on Japan would have been unthinkable without a way to land troops on defended beaches. The war would have dragged on for years longer, perhaps indefinitely, costing millions more lives. Alternative strategies would have had to be developed, strategies that might have involved even more devastating weapons or might have simply led to stalemate. But Eisenhower's praise was not about the elegance of the LCVP design or the sophistication of its engineering. It was about the fact that the boat worked in places where alternatives failed. It was about function over theory, practical results over academic correctness. The LCVP was not a beautiful boat. It was not a testament to advanced naval architecture. It was a blunt instrument, a crude solution to an impossible problem, a vessel that succeeded specifically because its designer had not been constrained by conventional thinking about how boats were supposed to be built. Andrew Higgins had looked at the problem of landing troops on a hostile beach and had not seen an engineering challenge that required years of research and theoretical development. He had seen a practical problem that needed a practical solution. His answer was to build a box with a motor and a ramp, make it shallow enough to reach the shore, make it simple enough to produce by the thousands, and make it functional enough that soldiers could get off it quickly and survive. The boat that resulted was not sophisticated, but on the morning of June 6, 1944, sophistication was not what the Allied forces needed. They needed something that worked. They needed it in massive quantities, and they needed it immediately. The story of the LCVP is not a story about genius or brilliance or revolutionary innovation in the traditional sense. It is a story about the difference between theoretical correctness and practical effectiveness. Naval engineers were not wrong when they said the boat violated fundamental principles of design. They were absolutely correct. The LCVP did have structural weaknesses. It did handle poorly in certain conditions. It was not an optimal design by academic standards. But it was optimal for the specific task it needed to perform. And that task was to land soldiers on beaches under fire and give them a chance to survive. There is a peculiar irony in the fact that one of the most critical military technologies of World War II was designed by someone with no military or engineering credentials, someone who approached the problem from outside the traditional framework of naval architecture. Higgins did not succeed despite his lack of formal training. He succeeded because of it. He was not constrained by the knowledge of what should not work. He did not have years of education telling him that cutting a ramp into the bow of a boat was fundamentally unsound. He simply built what needed to be built and let the results speak for themselves. The men who stormed the beaches at Normandy did not know the technical debates about hull design. They did not know that the boat carrying them toward shore had been dismissed by experts as impractical. They did not know that the ramp about to drop in front of them represented a violation of naval engineering principles. They knew only that when that ramp fell, they had seconds to get off the boat and onto the beach before enemy fire found them. The LCVP gave them those seconds. It gave them a chance. And for thousands of soldiers on hundreds of beaches across 2 theaters of war, that chance was the difference between life and death. Eisenhower's assessment was not sentimentality. It was a recognition of a hard truth. Wars are not won by the most theoretically perfect technologies. They are won by the technologies that function when and where they are needed, even if those technologies are crude, even if they violate established principles, even if they emerge from unexpected sources. The LCVP was never going to win awards for elegant design, but it won the war. The boats are gone now, most of them. Some were scrapped after the war ended, their metal recycled into peacetime products. A few survive in museums, preserved as historical artifacts, their ramps rusted shut, their hulls propped up on display stands. Visitors can walk past them and read plaques explaining their significance, but the plaques cannot convey what it felt like to ride one of these boats toward a defended beach, to hear the metal hull ring with bullet impacts, to wait for the ramp to drop knowing that the next few seconds would determine everything. The LCVPs are museum pieces now, relics of a war that ended generations ago. But on June 6, 1944, they were salvation. They were the only thing standing between Allied soldiers and certain death in the surf. They were the tool that made the impossible possible, that allowed men to reach shore quickly enough to fight to survive, to push forward into occupied Europe and begin the long march toward Berlin. They were crude, ugly, theoretically unsound boats designed by a man who had no business designing military vessels, and they changed the course of human history. Andrew Higgins did not live to see himself become a historical figure. He died in 1952, less than a decade after the war ended, his boat-building company struggling financially in the peacetime economy. There were no parades for him, no monuments built in his honor during his lifetime. He was a businessman who had solved a problem, a boat builder who had made something that worked when it needed to work. The recognition came later, after enough time had passed for historians to assess the war's critical turning points and to understand which technologies had truly mattered. The assessment, when it came, was unambiguous. Without the landing craft, vehicle, personnel, the Allied strategy for winning World War II would have been impossible. Without Andrew Higgins's willingness to ignore expert opinion and build a boat that should not work, D-Day would have been another Gallipoli, a slaughter in the surf that ended in retreat and catastrophic casualties. The crude box with a motor and a ramp, the boat that violated fundamental naval architecture principles, was as critical to Allied victory as any weapon system, any strategic decision, any battlefield triumph. Eisenhower knew this. The general who had commanded millions, who had coordinated the most complex military operation in history, who had access to every advanced technology and strategic resource the Allied nations could produce, understood that victory had ultimately depended on a simple boat designed by a Louisiana businessman with no formal credentials. It was the kind of truth that conventional military wisdom would have struggled to accept before the war. But the beaches of Normandy had a way of clarifying what mattered and what did not. Theory did not matter. Credentials did not matter. Elegance and sophistication did not matter. What mattered was whether a soldier could get from the boat to the beach quickly enough to survive, and the LCVP made that possible when nothing else could. That is the legacy, not the technical specifications or the production numbers or the engineering debates. The legacy is measured in the soldiers who made it off those beaches alive, who pushed inland and fought their way across Europe, who returned home after the war because a crude boat with a front ramp had given them 18 seconds instead of minutes, had given them a chance instead of certain death. Some of those men never knew Andrew Higgins's name. Some of them never thought about the boat that had carried them to shore, never considered the engineering decisions that had allowed them to survive those first critical moments on the beach. They simply lived their lives, raised their families, grew old, and died in peace because a boat builder from Louisiana had decided to ignore expert opinion and build something that worked. The question that lingers is uncomfortable. How many other problems remain unsolved because conventional wisdom declares the solutions impossible? How many critical innovations never happen because experts know too much about why they should not work? The LCVP is a reminder that sometimes the person least qualified by traditional standards is the one most capable of seeing past established limitations. Higgins was not smarter than naval engineers. He was not better educated. He simply operated from a different framework, one where the question was not whether a design satisfied theoretical principles, but whether it performed the necessary function. That willingness to prioritize function over theory, to build something crude that worked rather than something elegant that failed, was what made the difference. It was not heroic in the conventional sense. It was practical, pragmatic, almost mundane in its straightforward logic. But on the morning of June 6, 1944, that practical, pragmatic, mundane approach to problem-solving allowed 150,000 men to step onto occupied European soil and begin the liberation of a continent. The elegant solutions had failed. The theoretically sound designs had proven inadequate. What succeeded was the boat that should not have worked, designed by the man who had no business designing it, built in massive quantities by workers who had never built boats before. And that is why Eisenhower called Andrew Higgins the man who won the war for us, not because the LCVP was perfect, but because when perfection was impossible, Higgins had built something that was good enough. And in the desperate mathematics of war, good enough to save lives was indistinguishable from perfect. So here is the question that remains, the one worth considering as you think about this story. When have you dismissed a solution because it did not fit the established rules, because experts said it would not work, because it seemed too simple or too crude to be effective? What problems might be solvable if we were willing to ignore conventional wisdom and build the equivalent of a flat-bottomed boat with a front ramp, something that works even if it should not, something functional even if it is not sophisticated? The answer might be more important than we realize. It might be the difference between victory and defeat, between success and failure, between lives saved and lives lost. If this story changed how you think about innovation, about expertise, about the difference between theoretical correctness and practical effectiveness, hit that subscribe button and leave a like on this video. And tell me in the comments, what modern problem do you think needs an Andrew Higgins, someone willing to ignore the experts and just build something that works? I want to hear your thoughts.